Hey everyone, this is Tyler Berry back for another whiteboard session with TLA. Today we're going to be talking about air source heat pumps, or air source creating hot water type technology with heat pumps. There's a few things that I want you to keep in mind because this is going to be a new trend in technology, especially when it comes to hot water heating and potable water in terms of domestic water heating, is these heat pump technologies because of the push for electrification and decarbonization. So a few things I want you to take away is, one is the heat pump envelope for compressors. Now, every manufacturer tries to utilize potentially multiple types of compressor technology depending on the ambient temperatures in which they're designed around. But if they're designed around really cold temperatures, they may not necessarily perform at the higher ambient temperatures depending on the hot water temperature you need. So there's certain operating envelopes that you need. What I want you to stress to you about is understand your low-end demand and your high-end demand required of your compressors, and have a conversation with your equipment vendor about where you're operating, because this is critical to understanding not only peak demand, but also part load demand of when you need to be capable of producing hot water. Another thing to keep in mind is that as engineers, we understand bin data in our design envelope in terms of curves and performance and things like that. Traditionally with boilers, we're used to saying, hey, we're going to design to the 1% marker dictated by ASHRAE, and for Chicago at -3 degrees. We don't necessarily want to do that with air source heat pumps, because we have to realize that yes, as the ambient temperature goes down, just like the residential split system at your house that's a heat pump, the capacity or the ability to pull heat out of that air and utilize it is lesser than anticipated. So what we do to actually achieve a greater coefficient of performance, a more economical approach to solving heating with air source heat pumps, is to not design for this 1% condition. If we move out and get to this knee in the curve, what we call it, the knee in the bin data, what we see is that we can design around a 2.8% condition in terms of amount of hours per year, and we can drastically reduce the number of heat pumps we need. And you say, well, Tyler, well then what are we doing at peak demand? Well, we put an tank inside with a straight electric as supplemental MBH in the version of KW to boost up this temperature. You could also put the heater inside the unit like we do on the transom hatch units. So it's just something to keep in mind, and what happens is actually you get a better blended COP doing it this way, and you also save money because the heat pumps are going to be naturally more expensive than straight electric heating. The last thing I want to keep in mind is that every heat pump goes through a defrost cycle on occasion based on the demands put upon it. There's two different ways of approaching this. You can a lot of times reverse the heat pump, and then an alternate way of doing it is actually straight resistive electric heat built within the coil circuit itself. The problem is with the reversing the heat pump kind of operation is you end up with larger gaps in capacity and larger times in terms of demand that you're put on the system where you can't produce heat. So you end up losing production. Now, if you do straight electric, you're not reversing and switching that cycle. You can keep 92% of that heat. So some things to keep in mind are, where am I operating, when am I operating and designing to, and how am I handling a defrost cycle. Those are just three aspects of designing air source heat pumps for heating and potable heating demand. So if you have any questions, please reach out to us. I hope that was educational and something to keep in mind moving forward. Thanks again.